Curvilinear coordinate system 7. Determine divergence of the vector r, where vector r is the position vector x e x hat plus y e y hat plus z e z hat, and show that divergence of r is equal to 3. And then we will repeat this calculation using spherical coordinates. So I have to remember how to write divergence in Cartesian coordinates. Divergence operator is the partial derivative with respect to x, ex hat, plus partial derivative with respect to y, ey hat, plus partial derivative with respect to z, ez hat. So this must be applied to our vector. Now our vector in this case is the position vector written in Cartesian coordinate system x ex hat plus y ey hat plus z ez hat. So if I apply the divergence on this position vector, then I'm going to have a dot product between this and the r vector. Ex hat dot ex hat is 1, so I have del x of x. So partial derivative with respect to x of x plus the dot product ey hat dot ey hat is 1, so I'm going to get partial derivative with respect to y of y, and similarly ez hat dot ez hat is 1, so partial derivative of z with respect to z. And this is going to give me, for divergence of the position vector r, divergence of r, derivative of x with respect to x is 1, y with respect to y is 1, z with respect to z is 1. Therefore, I obtain my final answer. Divergence of r is equal to 3. And this was the suggested answer. Divergence of r is 3. So show that it is 3. In Cartesian coordinates, the divergence is straightforward. All you have to do is to consider the x component, y component, and z components of the vector and take partial derivative with respect to x of x component, of the y component with respect to y, and of the z component with respect to z, and add them up. So it's the del operator dot product with the position vector. In this case, x derivative with respect to x is 1, y derivative with respect to y is 1, z derivative with respect to z is 1. So we get 1 plus 1 plus 1, 3 as our final answer.